Hi there, this is another mini math lesson with Karen, and this one is about equivalent forms of linear equations. So just an exploration of how to help students see that different forms are used for different reasons depending on what you have and how they are equivalent to each other. So the activity again is free and it's shared in the description below the URL link, and all you have to do is type it in and it pops up the activity. And remember, you can just work on this activity. You don't have to have a ClassPad.net account, but if you do have one, which I recommend that you get because there's lots of free resources there, and you can also just create any math you want. But if you have an account, what you'd want to do if you want to modify or save this activity is go up here when you're in your account and hit duplicate, and that creates a copy for yourself. So here's the activity, linear equation transformations. And so the first part is on slope-intercept equation. So what I've done is I've graphed the parent function, y equals x, and if they want to explore that, they can display a table by clicking on the equation and kind of, what does that mean, y equals x? And so they'll notice that the x and y coordinates are the same. I can hide the table if I don't want it anymore. So basically what they're going to do is kind of explore adding in coefficients. How does that change the parent function? How does that transform? So you'll see there's some directions here. So first they're going to graph the equation y equals ax, and that's going to create a slider. So let me just do that a little bit right here. Whoops, a times x. Let me make sure I do that. What that does is create a slider here, and maybe I want to change the step a little bit. And they can then explore what happens as I move the slider. What's that doing to the parent function? So what is that coefficient a doing to the original parent function, and when are they the same? So notice I just put a on 1, and now the red line matches up exactly with the parent. So what does that mean the slope of the parent is? 1. And so a must have something to do with the slope. And so if I start exploring, well, what if a is negative? I should get a line that has a negative slope, and that's true, I do. You can also play around here with the range and change these numbers so that you can go a little further out. So now I could really explore a little further out here. So that's what's they're going to be doing in this first activity. I'm not going to do all of them, and in fact I'm going to erase this. Well, actually we don't need to erase it, but so next thing they're going to do is, okay, so what does this b, if I put a b coefficient in, how does that change the parent function? So they're going to learn about what is the y-intercept basically. And then the n, we're going to combine them together. So this is now the slope-intercept form of a line, and if you have a line in this form, you automatically know the slope and you know where it's going to cross the y-intercept. So that's what they're supposed to discover as they're exploring this first activity. The next activity is going into point slope equation, and you'll see that here's the parent function again in black, and then there's this purple line that has some coordinates here, and the purple line has been graphed. So each of these points represent C1, D1, and C2, D2, and we've kind of done the point slope form here. And the reason we did that is because now we can actually move these points and change that line. And what they're going to basically explore is, okay, so here's this line. How do I use those two coordinates, those 2 points, to help me find the slope and to find an equation? So they're going to explore, for example, if I lined it up exactly on the parent function, what do I notice about the coordinates? Oops, I moved the points somewhere far off there. Anyway, they're going to explore that. I messed up, so I'm going to hit undo, and that'll get me back to where I need to be. This is a nice feature of most software, is if you make a mistake, you can hit undo and get back to where you want it to be. There it is. And I wanted to put this point. There we go. And now my line will line up. So what do I notice about the coordinates if I have the purple line on top of the parent function? So they're going to just basically explore this form of the equation, and how do knowing just 2 points on any line help me figure out an equation for the line? How do I find the slope? How can I use those points to write the equation? And so you'll notice they're going to be moving the line a lot and coming up with different equations to match. So they're going to get a lot of little practice there. And then we move down to the last activity, which is standard form of a line. So again, we have the parent function, which you can't see right now because I happen to have the standard form one on top of it. And they start out looking, okay, this is what those values are if it's the same, exactly the same as the parent function. So how can we use this, knowing the parent's function slope is 1, how am I calculating that from these coefficients A, B, and C? So they're going to explore all that. They're going to use the sliders to change that red line and kind of figure out what are those coefficients doing in this form of the line, and how can I use that to help me find the slope and the intercepts. So they're going to be exploring that. So in each one of these, they're exploring a different form of linear equation, but always coming back to how do those coefficients help me find the slope, help me find the intercept, help me find points on the line. So that's where we're going at this. Lots of questions, lots of ways they can move and manipulate the lines and make comparisons back to that parent function. So good luck with that.